The second half of 6/4 is where it gets a little confusing and it becomes a lot. So really try to bear with me here. If you have questions, make sure to write them down so I can answer them. But before we get started with any sort of problems, we need to refresh ourselves over exponent laws. So all of this is based around when you have the same base, okay? So that is crucial here. So if you have a to the m times a to the n, all you have to do, since you have the same base, is add the exponents together. A power to a power, that's when you multiply the exponents together. And if you see a times b and they're both raised to the n with the parentheses around it, they both get the exponent. We've already looked at this property today. If we have a negative exponent, it gets moved to the denominator. If we saw this back in module D, that if we are dividing exponents and we have the same base, we are just subtracting the exponents. And then same thing here, if you have a divided by b and it's all around parentheses with the m, they both get that exponent. So keeping these exponent laws in mind, that's going to help us with problem number 4. So earlier, back in 6.2, we said that you can't divide unless they have the same index. And that still is correct. However, okay, if they have different indices, it's probably because one of them can be simplified. So on problem number 4 here, this looks a little overwhelming, right? Well, I don't want to rationalize anything going on right here. So what I can do is I notice that that 2 and the 8 can be simplified if I rewrite that as a exponent. So if I rewrite that as x to the 3/4 over x to the 2/8, that's the same as x to the 3/4 over x to the 1/4. And since I have the same base of x, and since I'm dividing, I can subtract my exponents. So that goes to x to the 3/4 minus 1/4. 3/4 minus 1/4 is 2/4. That's the same as 1/2, which in turn gives me the square root of x. Excuse me. You always want to write your final answer back in radical form. That is really, really important here too. Okay, always write your answer back in radical form. So let's keep this going with the next problem. We have the square root of 3 times the 4th root of 3, and again, normally we would say that cannot happen. However, if we rewrite them as rational exponents, I can make them have the same index per se. 3/2 is the same as saying 2/4. And since I can rewrite that, and since I have the same base and I'm multiplying, that's the same as adding the two exponents together. 2/4 plus 1/4 equals 3/4. So if we rewrite that back in radical form, that would be the 4th root of 3 cubed, and 3 cubed is 27. Same thing with part B. I'm going to rewrite this and say that's x to the 3/2 over x to the 2/3. And I know I can subtract, but I gotta make sure that those fractions have common denominators. So I'm going to make their denominators, or their index here, become a 6. So that means I would have 9 over 6, and then that's all over 4 over 6. And since I'm dividing, I subtract the exponents. So I would have x to the 9/6 minus 4/6, which gives me x to the 5/6, which gets rewritten as the 6th root of x to the 5th. 6 cannot go into 5, so that is simplified. And on the last one here, same thing. I have 7 to the 1/2 power times 7 to the 1/3 power. Since I'm multiplying and I have the same base, I want to add those exponents together. But in order to do that, I'm going to have a common denominator. So let's do 7 to the 3/6 times 7 to the 2/6. So I can add the 3/6 plus the 2/6. So that gives me 7 to the 5/6. And we're going to rewrite that as the 6th root of 7 to the 5th power, which is the same as the 6th root of, what is 7 to the 5th power? 16,807. And we're going to leave that just like that. So if you're multiplying or dividing with the same base, all we're going to do is get common denominator so we can either add or subtract those exponents. Now, moving away from variables, let's talk about how we would simplify the number using our exponent laws. Now, I'm not new to this. I obviously know you could type this in your calculator, but for some non-calc questions, let's see how we would handle this. So the first thing I want to do is change that 2.5 to a fraction, which is 5/2. And then you notice that it's a negative exponent, so we need to move that to the denominator. And what I'm going to do from here is I'm going to rewrite that 16 to the 5/2 as the square root of 16, and then I'm going to raise that to the 5th power. That's going to help me simplify this without a calculator, because I could have said, what's the square root of 16 to the 5th power all underneath that radical, but I have no idea what that number is, and it's going to be ridiculously large. So if I put my 5 on the outside, I should be able to simplify this a lot easier. So the square root of 16 is 4. 4 to the 5th power, that gives me 1 over 1024. Same thing on this next one here. We have negative 32 to the 4/5 power. So let's rewrite that as the 5th root of negative 32, and then we're going to raise that to the 4th power. Again, I don't want to put the 4 underneath there because I have no idea what 32 to the 4th power is, especially on a non-calc question. The 5th root of negative 32, you can type that in your calculator, but you should remember that that would give me negative 2. Negative 2 to the 4th power would give me a positive 16. So we can do all of these without our calculator very, very easily if we know our powers. So if you want to, we highly encourage you to try A, B, and C, but we can help you out here as well. I believe nope, I didn't do that one. So 32 to the negative 3/5 power, that's the same as 1 over 32 to the 3/5 power. So again, I want to write that as the 5th root of 32, and then that gets raised to the 3rd power, So that would give me 1/2 to the 3rd power, which gives me 1 over 8. On this next one here, 16 to the 3/4 power, that would be the 4th root of 16, and then that's cubed. The 4th root of 16 is 2. 2 cubed gives me 8. On part C, this one's going to take a little bit of extra work here. That's 9 to the negative 7/2 power. And then I can't have a negative, so that's 1 over 9 to the 7/2 power, which gives me 1 over the square root of 9, and then we're going to raise that to the 7th power. So that's 1 over 3 to the 7th, and 1 over 3 to the 7th. I don't know what 3 to the 7th is. Let me type it in. 2187. So again, very, very easy as long as you know your roots and your powers. So now that we've done the variable part and we've done the number part, let's see if we can put them both together. This is where it gets really kind of complicated. So you want to make sure you're following along and staying with me the whole time. So on part A, you notice that we have a lot going on here. The first thing I'm going to do is change the square root to the 1/2 power. And then from here, I'm going to say that that's negative 8x to the first power. That gives me x to the 1/2, y to the 1/2, and then that's all raised to the 2/3 power. So what I did was I just distributed that 1/2 power out. So then right here, I have a couple of x's, so I'm going to combine those and say that's negative 8x to the 3/2. 1 plus 1/2 gives me 3/2. And then I still have y to the 1/2, and then everything is raised to the 2/3 power. So a little bit of extra work in there I had to clean up first. Now I can move on and give everything the 2/3 power. So we're going to say negative 8 gets the 2/3 power, x to the 3/2 gets the 2/3 power, and y to the 1/2 gets the 2/3 power. So let's clean this up a little bit. We would have the cube root of negative 8, and then we're going to square that. That would give me negative 2 squared, which gives me positive 4. 3/2 times 2/3, that gives me 6/6, so that just reduces to x to the first. And then 1/2 times 2/3 gives me 1/2 times 2/3, which equals 2/6, which is 1/3. So I would have y to the 1/3 power, but we want to write our final answer in radical form. So we would say 4x times the cube root of y. That was a lot of work, and the only way to explain it is to actually go through the whole problem and do it. So if you need to pause or rewind or watch that again, I encourage you to do so. This is where all of our stuff comes together. So please feel free to go at your own speed and write down any questions that you may have. On part B, I don't have anything to take care of in here like I did on the last one. I had that square root and all that in there. I don't have anything like that here, so what I can do is I can go ahead and give my power out to the entities. So we would have that negative 3/4 given to everything. And from here, we can simplify. That would be 1/16 to the 3/4 power, which is the same as 1/4 root of 16, and then that's cubed. So that would give me 1/2 cubed, which is 8. So 1/8, and then here, power to a power, we multiply. Negative 8 times negative 3/4, that gives me 24/4, which is 6. So we would have 1/8 times, oops, sorry, not x, it's y. We would say y to the 6th. So we would write our final answer as y to the 6/8. So just a lot of little simplifying things. Nothing too crazy, but I know it does feel like a lot. So what we want you to do is we want to encourage you to try these two on your own. But if you still want to hang right here with me, you are more than welcome to. On the inside here, I have nothing to take care of, so I'm going to go ahead and distribute out my power of negative 1/3. X to the 15th times negative 1/3. So from here, I'm going to simplify this number here and say that's 1/8 to the 1/3. Well, that's the same as 1/, the cube root of 8, which is 1/2. Power to a power here, we're going to multiply 15 times negative 1/3. That gives me negative 5. So that gives me x to the negative 5. But I can't have a negative, so that's 1/x to the 5th. So I'm going to combine these two and say my final answer is 1/2x to the 5th. On part B, we don't have anything to combine. We just need to change that the 4th root of y. We need to say that's 9xy to the 1/4, and then that's times raised to the 3/2 power. So now I can give everything the 3/2 power. And I can simplify. This is the square root of 9 cubed. The square root of 9 is 3. 3 cubed would give me 27. X to the 3 halves, there's really nothing to do with that except rewrite it as the square root of x cubed, and then realize 2 can go into 3 one time with 1 left over. And then on this last one, power to a power, we're going to multiply. 1/4 times 3 halves gives me 3/8. So we would have y to the 3/8 power, which is the 8th root of y cubed. So my final answer, simplified together, would be 27x times the square root of x times the 8th root of y cubed. And I can leave it just like that. I don't have to make the x and the y under the same radicand. I could if I wanted to, but I really don't have to. And on this last page, if you want to try this one on your own, we would highly encourage you to do so. And if you have any questions with this last page, this is good practice and it's good preparation for the test. Wink, wink. Please let us know if you have any further questions.